In this video, we're going to go over logistic growth models. So some populations initially have rapid growth, followed by a declining rate of growth, as indicated by the graph in figure 4.29. Now, one model for describing this type of growth pattern is a logistic curve, given by the function y equals a divided by 1 plus b times e raised to the negative rx, where y is the population size and x is time. So an example is a bacteria culture that is initially allowed to grow under ideal conditions, and then under less favorable conditions that inhibit the growth. So a logistic growth curve is also called a sigmoidal curve. Let's do an example. So on a college campus of 5,000 students, one of the students returned from vacation with a contagious flu virus. The spread of the virus is modeled by y equals 5,000 divided by 1 plus 4,999 times e raised to the negative 0.8 t, where t has to be greater than or equal to 0. Y is also the total number of students infected after t days. So the college will cancel classes when 40% or more of the students are infected. So our first question is, how many students are infected after 5 days? So what we're going to do here is we're going to take our equation and we're going to plug a 5 in for our t, our time, 5 days. So we take that and we plug it into our calculator. I'm going to go ahead and have you do that really quick. You should get that about 54 students are infected after 5 days. So our next question becomes, after how many days will the college cancel classes? So at first we're going to calculate what that means. So remember that it's a college campus of 5,000 students, and they'll cancel it when 40% of more of the students are infected. So that's 0.40. So if I take my percent or my rate times how many students, that comes out to 2,000 students. So if 2,000 students have gotten sick, the college will cancel classes. So we're going to plug our 2,000 in for our y, just as we see here. So here we have 2,000 equals 5,000 divided by 1 plus 4,999 times e raised to the negative 0.8 t. So we'll multiply both sides by our denominator and divide by the 2,000. And that's going to give us 1 plus 4,999 times e raised to the negative 0.8 t equals 5,000 divided by 2,000. I can simplify this by taking out all those thousands. So I now make that a 5 over 2. And remember that we're trying to get the t by itself, so we need to move that 1. So we'll do so by subtracting 1 from both sides, which gives us 4,999 times e raised to the negative 0.8 t equals 3 halves. From here, we're going to divide both sides by 4,999 to get our e to the negative 0.8 t by itself. So we'll have e to the negative 0.8 t equals 3 halves divided by 4,999. Now 3 halves is really just 1.5, so we're going to replace our 3 halves with 1.5. We're going to take the natural log of each side to get the e to go away, because that's our inverse of an exponential, is a logarithmic. And that way we can get to our t. So by taking the natural log of each side, that allows the natural log and the e to cancel each other out because they're inverse properties, which leaves us with negative 0.8 t equals the natural log of 1.5 divided by 4,999. From here, we'll divide both sides by negative 0.8 to isolate the t. Doing that allows us to get t equals negative 1 divided by 0.8 times the natural log of 1.5 divided by 4,999. When we plug that into our calculator, we get that t is approximately 10.14, which means that about after 10 days, the college will cancel classes. And so that's an example of a logistic growth model.